Okay, so I want you to take a look at these two figures. You've got triangle ABC and you've also got triangle DEF. And I want you to try to list, take a few seconds and try to list some of the things that you notice that are kind of the same about these two figures. Not necessarily equal, but very close or like one another. You might even call them similar. So go ahead and take a second and try to come up with a few things that match. Okay, so assuming that you've done that, a couple of the things that you might have noticed about these two triangles are that their shapes are essentially the same, right? If you look at triangle ABC and you look at DEF, we can see that their shape, their general shape or their figure, right, is the same. We can let's say similar, okay, or close. We could even say close, right? Because they're almost exactly the same in every way except for the size of the shape, right? Their positions are the same, their orientation is the same, but their sides are a little bit different. One thing you also might have noticed is that their angles, the measurement of their angles, they're actually all the same. We call that congruent. The same, right? We call congruent the same. All right, so you can look at angle A and angle D, and you see how they have that same marking there. They have this little slash or this little curve here that marks them as the same. That means they have the exact same measurement. So say 30 degrees, right, or maybe 60. And so we can tell that they are congruent. And actually, all of their sides have the same markings, right? So A and D have the same thing, so they're congruent. E and B have the same thing, so they're congruent. And then angle F and C have the same markings, so they're also congruent. Okay. So a couple of those are the things that you probably know. So you could also maybe write down that their spacing or their we could say their spacing or their shape, their position, their spacing or position are the same. Same, right? Because obviously A and D match up together, they're congruent and they're in basically the same spot, right? They're not A isn't all the way down here where this H should be. It's basically in the same spot. So you're looking at these things and you're saying, well, hey, you know what? These are pretty closely related. They're pretty similar, right? And that's actually what we're going to talk about. We call these things similar figures, all right? When two shapes are essentially the same in every way, but their sizes are different, we actually call them similar figures, okay, or similar shapes, similar objects, however you want to say it, but we use similar figures. And there's actually a couple of ways that we can prove that these two are similar figures, okay? Similar figures have two main properties, okay? The first one is we say that their corresponding sides, or the sides that match, right? So if you look at A, B, and DE, their angles match up and their position matches up. Corresponding sides are proportional. Okay. And when I say proportional, I mean equal. Okay. So, for example, if we were to take two fractions, so let's say we took 1/2 and 2/4, right? We would say that those two are proportional to each other because they represent the same amount of space. If you took half of a pizza and then you took 2/4 of a pizza, right? If you took one out of two pieces of the pizza, you'd have half of it left. And if you took two out of a pizza that was divided into four pieces, you also would have half of that pizza left. The remaining pizza would be half. Okay. So we call these proportional because they're not necessarily the same size, right? If you have half of the pizza, that one piece is going to be different from the two pieces because they're two smaller pieces, but they take away the same amount of the pizza. Okay. So we're going to use that concept here for similar figures. And the other thing is that their corresponding angles corresponding angles are congruent. And we've actually already figured that out here, right? Because we looked at A and D and we said, well, look, their markings are congruent, right? So we've actually already kind of proven that one. And we've done that through E and F as well as B and C. They're connected, right? So we've actually already proven this one. So we're good here. But what about this corresponding sides are proportional? Is that true? Because I'm looking at 10 and 15 and then 6 and 9, 8 and 12, and you don't necessarily see how those two are related. Well, let's look here. Okay, let's take side AB and side DE and let's write them as a fraction. Okay, so I'm going to take side AB, side, not angle, right? Side AB, and I'm going to write that over side DE. Okay, right? Because if corresponding sides are proportional, okay, this should also mean that all of these together, all of the sides, if we write these as fractions, they should be equal to one another. Okay, they should be exactly the same. Okay, so let's take AB and put it over DE, and then let's also do the next pair, right? You've got BC, side BC, and side EF. So we'll take BC, and we're going to write that over EF, right? And then we can also take side AC, or well, let's do CA to kind of keep that going. CA, and we'll put that over FD. Okay. Now, if we plug this in, this should be true. If we plug in the measurements and reduce their fractions, this should be true. Okay. So let's take side AB, right? We know side AB is 6. We can see that that's a 6. And we're going to place that over the length of side DE, which we see is 9. Okay. And if we reduce that fraction down, we should get, right? If we take 6 and 9, they have a common factor of 3, right? We can divide both of those by 3. So I'm going to do that. And if we divide those two by 3, 6 divided by 3 equals 2, and 9 divided by 3 equals 3. So we actually get 2/3 as our reduced fraction for 6/9. Now, if we decide to do that with the rest of these, right? Let's do BC over. Let me move up just a little bit. BC over EF. Side BC, right? BC was 8. So let's just put that over here. Let's do 8, right? And we're going to put that over that corresponding side of EF, which was 12. And let's try to find a similar fraction for 8 over 12. We can divide 8 and 12. They're both divisible by 4, right? We can see that they're both divisible by 4. You can divide 8 and 12 by 4. 8 divided by 4 gives you 2. And then 12 divided by 4 gives you 3. And so far, this is true, right? We're good, at least between AB over DE and then BC over EF. This is true so far because they both equal 2/3, right? Now let's check with CA and FD, okay? So CA, the length of CA was 10. So that was 10. Right? And then the length of FD was 15. And if we simplify that, right, we know that 10 and 15 are both divisible by 5. So we can divide them both by 5. And if we divide 10 by 5, right, we're going to get 2. And then 5 goes into 15 3 times. So we also get 2/3. So far, all three of them are proportional. They're equal to each other, right? So therefore, these two figures are similar, okay? And again, you can also look, so this is good. And again, you can also look at the corresponding angles, right? A and D, those two are the same. B and E, they're marked as the same. And then C and F, those are marked the same. You could also do that, for example, if this was labeled as 60 degrees and this was labeled as 60 degrees, that would also denote them as congruent, okay? So you have to have two things. You have to have that corresponding sides are proportional, and you also have to have that corresponding angles are congruent, okay? And you can prove it like this.